In lesson 5.4, we're going to talk about special quadrilaterals, and obviously with special quadrilaterals comes some words that in situations where we've already encountered. We're going to learn the differences and properties of the parallelograms with rectangles, rhombuses, and squares. We'll also mention kites and trapezoids as well, just to go over them. In the special types of parallelograms, every one of these types has these two properties guaranteed, with two sets of parallel sides and opposite sides congruent. We also know, obviously, opposite angles, and we also know that diagonals bisect each other, and that holds true for each one of these three special parallelograms. The additional piece that we can add with the definition of a rhombus is that we know that it's a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles, and a square holds both properties of four right angles and four congruent sides. The flowchart you see here is just going to give you an idea of where and what characteristics you could have for those always, sometimes, and never situations. If we work backwards, a square holds the properties of both a rectangle and a rhombus. A rectangle holds the properties of just a parallelogram. A rhombus holds the properties of just a parallelogram, and a parallelogram holds the properties of just a quadrilateral. When we have a kite is a certain figure where adjacent sides are congruent and the diagonals form 90-degree angles. A trapezoid has one pair of parallel sides, and an isosceles trapezoid has the non-parallel sides to be congruent, whereas a right trapezoid has one side perpendicular to both parallel sides. In situations where we have always, sometimes, and never, a square is always a rectangle, but a rectangle isn't always a square. Same thing with rhombus, where as we work down the flowchart, the answer would be sometimes, but when we work up the flowchart, the answer would be always. A square is always a parallelogram, a square is always a rectangle, and a square is always a rhombus. A couple of theorems that we have from this lesson are that the diagonals of a rectangle are congruent, which means not only do they bisect each other, but they also remain congruent with each other. With diagonals of a rhombus, they are perpendicular to each other. So not only do they bisect each other, but they are also perpendicular to each other. The diagonals of a rhombus also bisect the angle in which they intersect. So for instance, these angles are congruent, and so on. The midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. You could see how if we cut a rectangle or a square in half, we could also determine that the segments from the right angle are also congruent to where it bisects on the other segment. If we know it's a parallelogram and we know a parallelogram has one right angle, we can also determine that this parallelogram is a rectangle just by the one right angle, and I'm sure you can figure as a proof why that would be true. If two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Now, we've determined in previous slides that a parallelogram with consecutive sides congruent could be a square, but it's definitely just a rhombus. In the previous slide, I mentioned that kites have consecutive sides congruent, but also that two disjointed sides would also not be congruent. The properties different from a kite and a rhombus is that a rhombus is a parallelogram, whereas a kite is not. One final flow chart I'll ask you to hit pause and take a look at. These are all the possible characteristics of parallelograms and trapezoids and kites that would fall under certain things. On your worksheet, at this time, I'd like you to turn to the front and find the answer to questions 1 through 5. Once you have that answered, please turn to the back. Answer questions 6 through 21 by yourself.